AI has just achieved an amazing milestone in science. At Carnegie Mellon University, an application called Coscientist was able to recreate a Nobel Prize-winning chemical reaction and to design a successful laboratory procedure to reproduce it and to run that procedure in a cloud-based lab, all without help from humans. Here's a look at the prompt that did all that. As named for their inventors Akira Suzuki and Kenkichi Sonegashira, these reactions use metal palladium to catalyze bonds between carbon atoms in organic molecules. As you might infer from this explainer video, and from the fact that, after all, the result won a Nobel Prize, this is not a task for beginners. To perform its task, Coscientist first researched sites ranging from Wikipedia to American Chemical Society to Royal Society of Chemistry, and also sites containing academic papers. Then, in less than 4 minutes, it designed an accurate procedure for producing the 2010 Nobel Prize-winning reaction. Needless to say, this could revolutionize material science. Pharmaceutical companies, take note. But what is Coscientist? Well, it's 100% open source. The small research team involved in this experiment included a pair of doctoral students under the direction of one faculty member. One of the students was Daniel Boyko. Here's his LinkedIn page. The faculty member was Gabe Gomez. Here he is. And the other doctoral student team member was Robert McKnight. That's him on the left, with Daniel on the right and Gabe in the middle. Here's the co-scientist page on GitHub. You can see Boyko and McKnight there in the lower right. And as you can see here, the code for this application was written in Python. And you can see here that the large language model that was used was GPT-4. Here's how it was programmed using text prompts. It's interesting how Coscientist was trained. Part of the training process asked the model to figure out how to create things like aspirin, acetaminophen, and ibuprofen. It was able to do that. In another part of the training, it was taught how to direct the activity of robotic lab equipment. Here's what it was told to direct lab equipment to do. Draw a blue diagonal. Color every other row with one color of your choice. Draw a red cross. And draw a 3x3 rectangle using yellow. I wouldn't know how to do those things with lab equipment. As a result of the training, Coscientist was able to conduct experiments without the help of people. And that's possible because of facilities like Emerald Cloud Lab, where robots perform the experiments as directed by computer prompts. But this was the first time that such robots had ever been directed by computer code that was written and sent directly by AI. And Coscientist is also able to find and read technical manuals on how to control robotic lab equipment and then write computer code to carry out the tasks it's been asked to do. And it's interesting that when it first tried to carry out this procedure, it made a mistake in the code it wrote to the device that heats and shakes liquid samples. But then, without any prompting from the Coscientist team, it spotted the problem, referred back to the technical manual for the device, corrected its code, tried again, and this time was successful. The final lab results were verified, and they did indeed contain the hallmarks of a true Suzuki Sonogashira reaction. It did it. Amazing, huh? Now, beyond the obvious implications for drug discovery and other directly related use cases, what do you think are the takeaways and implications of this? I think the implications could be significant. After all, this was originally a Nobel Prize-winning achievement, and it was reproduced in 4 minutes by a small team of about 4 people, including 2 very talented graduate students. Imagine. Think about even Fortune 500 companies with all their many resources. They don't have to win a Nobel Prize in chemistry or in anything else in order to successfully compete and win in the marketplace. All they have to do is consistently make the best possible decisions, execute those decisions well, do it quickly, and do so across the entire enterprise. Well, generative AI copilots are designed for all those things. So for me, this new milestone in AI reconfirms the apparent enormous potential of these copilots. The ability to accelerate innovation and improve decision making at this level means that today's copilots are surely a powerful option for any company that's looking to gain a competitive edge. And by exploring what these copilots can do, the first wave of early adopters will likely gain a competitive advantage, maybe transforming their workflows and probably achieving new heights of operational or financial performance, possibly at levels never seen by their shareholders before. That's something to think about.